today I have discussed very important topic, impulse, or you can say that linear impulse. How can define? First of all, I know that according to Newton's second law, external force, net external force, it is written as dp by dt. Clear or not? So this one is also written as dp is equal to f external into dt. Okay. Now this one is also corresponding to here P1 to P2. So you can say that P2 minus P1 is equal to F external into dt. That is change in linear moment. It is written as F external into dt. Clear or not? So you can how can say this one is defined? Change in linear moment, that is called impulse. Very simple. Okay, change in, you can say that is change in linear moment. Linear that is called impulse. That is called impulse. That is linear impulse, or simply you can say that is impulse. Clear or not? Clear or not? It is represented also by J. It is also represented by J. Okay. You can say that J this is equal to delta P, this is equal to, clear or not? It's P2, here P1. Change in linear momentum, that is called linear impulse, or simply you can say that impulse. What is the physical significance? Okay. I know that, suppose that this one is a bat. Okay. If you hit the ball by bat, let's suppose that a ball like that one, bat like that one, that time if bat hit the ball and this one is going on very large velocity, okay, suppose that is 5 meter per second, after 10 to power 4 Newton here, okay, force exerted by bat and hit the ball, then this one is going on near about 500 meter per second. And what about delta t? Delta t is equal to 10 to power minus 2 second. What is the meaning of that one? Clear or not? For very short duration, you can say that here also, for very short duration of time, large force exerted on the ball or body or particle, okay, that is called impulse. Clear or not? You can hit the ball very short duration of time. If you ball hit the bat very short duration of time, then means in that particular time, what about if you draw here, that is force and here time. Very short duration of time, large force generate and after that dissipate suddenly. Means force increases and after that suddenly decreases. 10 to power 4 Newton force generated, hit the ball for contact period 10 to power minus 2 second or very few second, that is you can say that millisecond or micro. What about time? That is millisecond or you can say that microsecond. So you can say that how can define impulse? If a large force acts on a body or particle for a very short duration of time, that is called impulse. Clear or not? What is the meaning of that one? Okay. So you can define very simple way. If very large force act on a body for very short duration of time, act on a body or a particle for very short duration time. Short duration means here milli or microsecond. Okay, that is called impulse. Clear or not? In general, that force is variable. That force is very time dependent variable. Clear or not? Look like here. So then what about delta P? Impulse, or you can say that change in linear moment. Okay, or you can say that is change in linear moment. Clear or not? Simply. So basically you can say that if you draw here, if that is force, here time, force like that one, and time in milli or microsecond, area under this one. So area, it is F into dt. F into dt, that is delta P. That is delta P. Clear or not? This is the impulse. This one is called impulse. Clear or not? Now next target. So if F is constant, if F is variable, then we got like that one using this formula, and we got delta P. Clear or not? If F is constant, then what about delta P? Delta P is written as, if F is constant, then you can say that F into delta T from T1 to T2. So you can say that F into delta T. So delta P is equal to F into delta T. Okay. This formula used only if capital F external is constant, then apply that formula and we got whatever be the value. Clear or not? P2 means that is final linear moment, and P1 is initial linear moment. It is also written as P final minus P initial. Okay, you can say that what is the meaning of linear moment? Linear impulse or impulse. If large force act on a body or particle for very short duration of time, that is called impulse or linear impulse. Clear or not? Make it. After that we have focus on numericals. Okay, make it. Now corresponding question. A ball of mass 2 kg lie at rest in a smooth horizontal surface. Means what about initial velocity? That is 0. Okay. Experience a time dependent horizontal impulse force is given like that one. This horizontal force act on a time interval 0 to t is equal to 0 to t is equal to 0.1 second. Then find impulse of the force. Our motto, determine impulse. I know that delta P, this will be equal to F external into dt. Okay. Now from T1 to here T1 to T2, so F is given how much? 2 into 10 to power 5 into T I cap. What about time? T this will be equal to 0 to T this will be equal to 0.1 into dt. So 2 into 10 to power 5 into T square divided by 2 into I cap. Okay, from 0 to 0.01. So finally we got how much? 10 to power 5 into 10 to power minus 2 to the whole square into I cap. So finally we got 10 into I cap, that is Newton into second. So impulse is written here 10 I cap Newton into second. Clear or not? Very simple. Put the using this formula and put this value and we got final answer. Next one, final velocity achieved by the particle. Now next target is final velocity. I know that delta P is written as P final minus P initial. Okay, that is 10 into I cap. Final mass into velocity, so 2 into final velocity, like that one. But what about initial velocity? What about initial moment? 2 into Vi. Vi is 0 because of it is start motion from rest, so that is 0. So 10 into I cap. So final velocity it is written as 5 into I cap, that is meter per second. That is meter per second. In which direction? I, positive x direction. Clear or not? Make it. Now corresponding question, first of read the question. A ball of mass 0.2 kg, okay, is moving with velocity 5 meter per second in positive x direction. Then it experiences constant impulsive force of magnitude 10 to power 4 Newton. Okay, for 10 to power minus 2 second in negative x direction. Find due to impulse of the force final velocity achieved. Our motto determine final velocity. Okay, impulse of force and final velocity. I know that. What about delta P? Delta P is written as F into, here force is constant, so you can use here T1 to T2, that is delta F into delta T. Very simple. Okay, so delta P is written as, now what about force? A ball is moving like that one. Okay, the constant impulsive force magnitude 10 to power 4 Newton for 10 to power minus 2 second in negative x direction. It means F is written as minus 10 to power 4 Newton into I cap. Clear or not? So if put this value minus 10 to power 4 into I cap into what about delta T? Delta T is 10 to power minus 2 second. So it is written as minus 100 into I cap. That is minus 100 into I cap. What about unit? That is Newton into second. That is Newton into second. That is Newton into second. Clear or not? Now next target. Our next target is final velocity. Delta P is also written as this one is also written as this is 100 into I cap minus 100 into I cap. What about final velocity? I don't know. What about mass? 0.2. So 0.2 into final velocity minus what about initial velocity? According to question, a ball mass took 0.2 kg, that is 0.2 kg. Okay, moving with 5 meter per second in positive x direction. So 5 into I cap, this will equal to 100 into I cap. So 0.2 into final velocity, it is written as 100 I cap, and this one is going on here. So plus 5 into 0.2, it is written as 10, means 1. Simply 1 into I cap. Simply you can say that I cap, or you can say that minus 99 I cap. So final velocity, how much final velocity is minus divided by 2 into I cap. So it is written as minus 495 into I cap, that is meter per second. Clear or not? That is meter per second. Clear or not? Very simple. In negative x direction, with how much speed? 495 meter per second. Very large speed. Okay, as compared to this one. Okay, make it. So impulse is like that one, and final velocity like that one. Make it.